We're going to use the alternating series test on three alternating series and decide whether these converge or diverge. So the first series, recognize this as the harmonic series except alternating. The harmonic series is our most famous divergent series. 1 plus a half plus a third plus a fourth plus a fifth. In this case, it's alternating. So I think we have -1 plus a half minus a third plus a fourth minus a fifth. Let's see if that makes a difference. Now the conditions of the alternating series test are that the series is alternating. So check, it's definitely alternating. -1 to the k, it's changing sign. There's no other place this could change sign, so it's alternating. And 2, are the terms decreasing to 0 in magnitude? And so in magnitude, we're looking at just at the positive or the absolute value of the terms. So 1, 1/2, 1/3, 1/4, 1/5. Those are definitely decreasing. They're definitely decreasing to 0. So check. This converges. So that's a convergent alternating series. And that's how easy it is often to apply the alternating series test. Let's look at the second one here. For the second one, this is clearly alternating. Check. We have the -1 to the k again, so it's alternating sign. It might take a few times to alternate sign because I think when we put in k equals 1, we get a negative in the denominator. But as long as it starts alternating sign, if the first few terms don't, that's fine. It's okay. So this is alternating. Are the terms decreasing to 0? If we look at the limit of the terms, the limit of the a sub k terms, or even the limit of the absolute value of the a sub k terms. If we ignore the -1 to the k and just look at the limit of those terms, well, that's a polynomial divided by a polynomial, and they're the same degree. So that limit is the coefficients of the highest degrees. That's 1/2, which is not 0. So this does not meet the conditions of the alternating series test. And in fact, the limit of the terms is not 0. That's the test for divergence. That means this is a divergent series by the test for divergence. If the terms that we're adding together don't go to 0, the series can't possibly converge. It can't possibly settle down to some limiting value. So this is a divergent series. It does not meet the conditions for the alternating series test. And in fact, we can see by the test for divergence that it diverges. And the last one here, we clearly have an alternating series. It's changing sign. Are the terms going to 0? Does the natural log of k over k approach 0 as k goes to infinity? We could look at that limit. The limit as k goes to infinity of the natural log of k over k. And that looks like an infinity over infinity indeterminate form, so we can use L'Hopital's rule on it. The derivative of the natural log of k is 1 over k. The derivative of k is just 1. As that goes to infinity, 1 over k, as k gets bigger and bigger, that approaches 0. So that limit is 0. This limit is 0. The terms are decreasing in magnitude to 0. They're getting smaller and smaller. In fact, the first term is a 0, and then the second term is non-zero. So at the very beginning, the term gets bigger, but then from that point on, it gets smaller and smaller. And as long as it gets smaller and smaller to 0 at a certain point, we can apply the alternating series test, and we can conclude that this is a convergent series. So really, there's just two things to check. If we have an alternating series, if you see the -1 to the k, or k plus 1, or something like that that makes the terms alternate, then all we have to look at is, are the terms getting smaller? Do they get smaller to 0? Do they approach 0 in the limit? If those things are true, then we have convergence.